7.7 applications, including minimum and maximum. Boom. Yeah, maximum, minimum, that's just vertex stuff, by the way, so don't, it's just another way to say vertex, maximum, minimum. Because it's the peak or the lowest, the trough of the parabola. Anyways, when solving for a non-maximum or non-minimum value, they'll have to tell us which value it is, either y or x. So we have to look at the context of it, and then whatever equation that they give us. So when solving for the y value, plug in the x values as dependent. When solving for x values, the independent variable make the equation equal to 0. Again, it depends on the context that's given to us. Sometimes we just have to put in whatever it goes, whatever values they give us, and then find the corresponding value that they give us. And yeah, factoring is good. Using the quadratic formula is nice as well. Negative b, and this is, of course, the fraction negative b plus or minus the square root of b squared minus 4a squared all over. I almost did it. Okay, so an object is thrown upward at a speed 192 feet per second by a machine from a height of 20 feet off the ground. The height h of the object after t seconds can be found using the equation that round answers to the nearest hundredth, if we need to. When will the height be 494 feet? It should happen twice. When will the object reach the ground? So it's saying that it's happening twice, okay? So if you take a ball, an object, I guess, and you throw it upwards, let's say that you throw it, trying to make this a little better. Let's emphasize it even better, something like this. That's okay, all right? So we'll pretend like I can draw very well. But if it reaches a height of 494 feet right here, you can see it happens here and then right here as well, ish. Okay, so yeah, it's not really dealing with the vertex so much, but it is that height. And so it should happen twice, which means that if we solve this, we should end up with two answers, which is what we'd expect, because it is t squared. 2 different times, it should end up at this height. Now, the other thing we know is that h of t here is the actual height. This is the height.
So the height's good. Its highest point's going to be more than.
Yeah, now that's a really long height, or it's a very high height for throwing something, unless you're using a machine to throw it, I guess. But the height here is 494 feet. Okay, so I'm going to take this, set it aside, so we'll come back to this, okay? But just want to set it aside for now, so that I have some space to work with. All right, so the equation then becomes, it's h of t. Instead of h of t, I've got 494, which equals negative 16t squared plus 192t plus 20. It's the exact same equation, but now we know what it does equal. And so like I said, sometimes it gives you a value, then you have to put it in there. If it said, how high is it after 10 seconds, then you'd have to replace the t with 10. But this one gave us a height instead. So we got to solve this. And like we saw on that last slide is if we're solving, in this case, for the independent variable, t, which would be also an x, then we want to make this equal to 0 so that we can use the quadratic formula. So I'm going to subtract 494 from both sides in order to make this equal to 0. Okay, so I do now have 0 equals negative 16t squared plus 192t, and this then becomes negative 474. So from here, I'm looking for that height of 494. So I've now manipulated the equation, so it's something a little bit more familiar. This, you could work with these values, I suppose, but I don't think you can. It's even telling us that you should round, which means that we're probably going to end up with some very not so fun looking factoring on this one. And that also means for me, with a little bit more space here, that I'm going to go to the quadratic formula. All right, so it's negative b. Again, we'll do it twice in the calculator, but it's square root of b squared minus 4 times a times c, all over 2a. And what I have right now, I am showing an a value that's negative 16. I'll put the negative 16 where the a's go. And then I've got a b value that's 192, which is rather large, positive 192. And then a c value that is negative 474. All right, so I should get two values out of this for x, and that should be the amount of time it takes for the ball to reach 494. So I'm going to start with a plus, all right? So let's take this calculator, n over d, negative 192, and we're doing plus the square root of 192 squared minus 4 times negative 16 times negative 474, all over 2 times negative 16. Enter, and it gave me the decimal directly. It didn't even give it to me in square root format. It said to round to the nearest hundredth. I have 3.475, so the 7 I would add 1 to make that 3.48. That'd be in seconds right there. Okay, now that's one of the values. That was from the addition part. Now I'm going to use subtraction between there and get another x value. So in the calculator, again, I'm just going back to the equation
Is this for
here.
seconds?
Yes,
Thank you.
S is for seconds there. So I'm just going back into the equation here. I'm not going to retype everything. I'm just going to change that plus with a minus, enter, and it says, okay, if you use minus there, you would have gotten 8.524, so that just stays 8.52 seconds. And these are approximations because we did have to round, but that's how long, that's how many seconds it will take to reach 494 feet. So 3.48 seconds it reaches here, then it goes up and then back down. After 8.52 seconds from when it was thrown, then it comes back here, and then it's on its way back down to where the ground, I guess. Yeah, it's true. Well, if it's going to reach the ground, then that would tell us that we would have originally had a height. The ground, that's where the height is 0. Okay, so this goes back to the original equation, right? So instead of h of t, I now know that the height is 0 is going to equal negative 16t squared plus 192t plus 20. Okay, so again, you can factor it, which I don't know if it's going to work, but I am just going to use the quadratic formula. So here I see that a is negative 16. Here, the b is 192, which is, it kind of matches what we had up above, but now the c value is just the original one that was given at 20. So we're going to put this back into the quadratic formula, plus or minus with some square root, fun business. See if I can fit that stuff in there. So if the a is negative 16, so let's put that in there. It's negative 16 once again. And then the b value, once again, is 192. And then the c value is 20. All right, so I'm going to start with a plus again in my calculator. Let's go back in there and punch this in. Okay, so this one, it gives me a negative value, and I can't have a negative time on this one. So it says it was negative 0.103. I'll just make it to the 10th again. Again, I can't have the negative right there, so this one is invalid. So that means if I use the subtraction here now, I should get a valid time on this one. So again, just type it in, or I'm just going to go back in and replace.
Was that a negative 0?
Yeah, so I'm just replacing that, but it appears that after 12 again, round to the nearest hundredth, there would be 0.10. After 12.10 seconds, this ball would then have hit the ground again, which would be, we'll put it right there in the ground. So again, you throw it, it's right here. That would have been 20 feet off the ground because that's where it starts there. And then after 3.5 seconds almost, it's 490 feet high. Then it reaches the vertex, which we didn't ask about, but then it comes back down, reaches 494. 12.1 seconds later, after you've thrown it, then it's hit the ground. And yeah, it could bounce after that, but whatever. So that negative 0.10 seconds, I know was rounded. But if we go back to this diagram over here, that means that since it started right here, 20 feet off the ground, to hit the ground again, you would have had to have gone back in time right here to have hit the ground right there. And yeah, we get to assume the ground is level, but maximums and minimums, or word problems, 4-word problems, are usually the vertex of the equation. That's true. Now, you can change this into vertex form, but I like the vertex formula. You're welcome to use the vertex form if you really want to, but it's up to you. A patient has an illness that typically lasts about 24 hours. The temperature T in degrees Fahrenheit of the patient T hours after the illness begins is given by this function. Round all answers to 1 decimal place. So we're expecting some kind of nasty stuff to happen on this one, but when does the patient's temperature reach its maximum value? Its maximum value when? When is the time on this one? There's 2 T's on this one, because it can be kind of confusing, but they clarified up here, the lowercase t is the time in hours, the uppercase T is the time, or the temperature in degrees, rather. So we want to know when the maximum value happens, meaning the temperature. Okay, so we want a maximum T on this one. It says when, that's the time. So what time would it be on this one? That's the X value. This lowercase t is replacing the X on this one. And we know that that can be found in the formula with negative B over 2 times A. So the B value that they gave us was 0.3146, which isn't very pretty, but it still works, 0.3146. That's my B, all over 2 times A, and then the A value is the coefficient of T squared, which is negative 0.013. So again, I just put that in there, negative 0.013. I put this in the calculator. Let's see what we get. Now, just from the calculator there, I got 12.1. And this was when, so that's in seconds. 12.1 seconds. That's, not seconds. This was in hours, right? Up there at the top, so not seconds. This one was T in hours, so at 12.1 hours after, I guess, the illness starts, that's when the patient's temperature will be the highest. The next question says, what is the patient's maximum temperature during the illness? Well, the maximum temperature has to happen at the time that it reaches the maximum temperature, which is 12.1 hours after it begins. So that means that in the function, negative 0.013 T squared plus 0.3146 times T plus 97.5. Instead of T's, now I know the time is going to happen at 12.1 hours. So I just replace those T's with 12.1. And again, this is just something I'm going to type into my calculator, and this will tell me the maximum temperature. This is, by the way, it would have been shown as T of 12.1, which is kind of how we've seen how you find the corresponding Y value there, which is really all this is. So let's put this in. I got negative 0.013 times 12.1 squared plus 0.3146 times 12.1 plus 97.5. Enter. And it says, seems kind of low, but the maximum temperature is showing as 99.4. Well, it said 1 decimal place, didn't it? So I have 40333. So I'll just make it 99.4 degrees. Wow, that's kind of steep for an illness, I guess. But maybe this one's just not that tragic or dramatic, I guess. Well.
No, I'm just asking. I'm not picking.
Well, it did say Fahrenheit. Let's put it on there.
Okay.
Fahrenheit. I'm not going to put Fahrenheit. Just F is good. To write a quadratic equation for a line that intersects 3 points, you will need to make a system of 3 equations by replacing the x and y values in the equation, because that's what it gives you. Okay, so remember, we have this format here, y equals ax squared plus bx plus c, which we love so much. But in the ordered pairs, they're going to give us 3 ordered pairs. 1, 2, 3, something like this. And then you got x and y values throughout. Okay, this is saying that what you got to do is you take those x's and replace it with whatever x value is given, and then whatever y value is given, but you got to do it 3 times. And this will create a system of equations with 3 variables that are now a, b, and c, not x's and y's. And as funky as that sounds, it is so fun.
James Brown.
Almost, yeah, like James Brown. Mm-hmm. So write the quadratic equation for the line going through the 3 points, -217, 1,5, and 429. Now, I need 3 equations out of this, one for each ordered pair, by the way. And so we got to remember the standard form for our quadratics. Now, the first one, I'm going to make this equation red because this is for the first ordered pair where the x is -2 and the y is 17. So, for y equals ax squared plus bx plus c, I know the y value is 17 right now, and I know that the x values are -2. Okay, so writing this out, I've got 17 equals a times -2 squared plus b times -2 plus c. And to simplify this then, would become 17 equals -2 times -2 would be 4, so that's 4a. And then, well, -2 b's, and then plus the c. Okay,
Okay.
that's my first equation. But I've got to do it with all 3 ordered pairs. So we get the pleasure of doing this all over again, but with the new ordered pair. So let's do the 1,5. I'll do this one in purple because it's just my next color. But again, it's the same idea. The y value here is 5. The corresponding x values are just 1s, and that's nice. Because 1s is pretty easy to work with. But now I get 5 equals a times 1 squared plus b times 1 plus c. And this just ends up being 5 equals, you can make it 1a if you'd like. In fact, I will show the 1 because I think it's going to make things easier. And then even the coefficient of b, I'll show that as 1 as well. Okay, so this in purple, 5 equals 1a plus 1b plus c is my second equation. But I need my third equation to make it triple the fun. So the third ordered pair, the x is 4, the y is 29. So I've got a 29, and then again, all my x's are replaced with 4s. So I've got 29 equals a times 4 squared plus b times 4 plus c. And we'll simplify this. So 29 then equals 4 times 4 would be 16a. And then plus 4b, yep. There's my b plus 4b's. And then plus the c. This is my third equation. Now, we probably are not used to seeing the equations written like this. So what I'm going to do is I'm going to restack these so that it looks more like a system of equations. So there's my first equation that we found, the second one. It doesn't matter which order you find them in, by the way, just as long as hopefully you find them. And then, of course, we have the green one here as well. So this is my system of equations that will help me to solve for the a, b, and c, which is the original quadratic for all 3 of these ordered pairs, meaning that once we find the a, b, and c for our quadratic, you could have replaced these values into that quadratic, the same quadratic, and you get true statements out of it, if that matters to you. But my system of 3 equations, if you have experience solving these with matrices, feel free to use that. But since we haven't in this class, I'm not going to, as much as you want me to. So I would probably look at these 3 right here, and I'd say, you know what, I can get rid of those c's pretty easily. Okay. In fact, I could probably get rid of the a's or b's pretty easily just because of this equation right here in the middle. But I'm going to leave it up to you guys. What do you guys want me to eliminate first? Let us eliminate the c's then, because it has been declared. All right, so I'm going to take the first 2 equations. We have chosen to eliminate the c's. We'll see how that goes. And from this, I know right now the c, I got my c's. Their coefficients, by the way, are 1s. But I need them to be opposites. One's positive, I would like for one to be positive and one to be negative. And so to do that, I'm just going to change the signs of the second equation. Of course, that'd be multiplying by -1. The reason why I'm doing that is because when I add these 2 together, now, in these columns, which match, let's start on the left. I got 17 minus 5, which is 12, which equals 4a's minus or plus negative 1a's, which would be 3a's. And then I've got negative 2b's plus negative 1b's, which would be negative 3b's. And then the 1c, and now it's minus 1c, has zeroed itself out as planned. Yeah, so multiplying all these values by negative 1 is what changed those into minuses for us, essentially minuses. And that did eliminate the c's, because before they were the same coefficient, positive 1, I need them to be opposites. So positive 1 and negative 1, and that does eliminate them. And this is a fairly decent looking equation. 12 equals 3a minus 3b. If you wanted to simplify that by dividing everything by 3, you could. But I'm gonna avoid that because that may not be so obvious to everyone.
Take away from the
Yeah, now I've got to do it again, and I'm just going to use the bottom two equation. I used the top two first, so I'm going to use the bottom two now to eliminate, again, the c. And by doing this, I will then have a new system, but it will only be in two variables. So let's take a look at that. Now, again, I have the same problem. The c's have the same coefficient of positive 1.
Would this be the order you have?
This goes back to, I think it was module 2, but yeah, I chose the top two and then I chose the bottom two. One of them you always end up having to use twice no matter what in a system with 3 variables like this. And so I chose the top two, but if you wanted to, for some reason, choose the top one and the bottom one, you could. You could have combined those and then eliminated the c's again, or the a's or b's, whatever you're eliminating. But we've chosen the c's. So right now, I have the same problem. I have a 1c and a 1c. That's not going to eliminate if I add these together. So I'm going to have to make that a negative 1c right there by just, all I'm doing is really changing the signs there. And now I can combine these with addition. I am changing the bottom one because usually it's easier to see that it'd be subtraction right here with this stuff. But you could, if you wanted to say, okay, keep that 29 positive and the 16a positive and the 4 positive and the 1c positive, you could. And then you could have made this negative 5 and negative 1 and negative 1 and negative 1. You could have done that, yeah, you could have. And that's the beauty of elimination with systems with 3 variables. There's so many directions you can go, and you can have so much fun doing it. All right, so let's eliminate then. So 5, I would just say 5 minus 29. There's going to be negative 24, which is going to equal 1 minus 16a's would be negative 15a's. And then 1b minus 4b's would be negative 3b's. And then again, the c's have eliminated as planned. So we now have 2 equations, and that gives us a system with 2 variables. So let's write these again. Let's take these and separate them. These problems, they are long, okay? So you have to be careful. If I've made a mistake right now, it's going to really do a number on us later on. So we got to be careful. So negative 15a and then a negative 3b. Oh, this is great because as it is right now with the b's, hey, look, the coefficients are the same, negative 3 and negative 3. All I got to do is change some signs, and they will eliminate as well. So that's what I'm going to do.
It's 2. So it's negative.
Okay, so I'm going to change those signs. Again, I like to change the bottom ones. You're welcome to change the top ones, but that'd be a positive 24, positive 15a, and then a positive 3b. Maybe I should have changed the top ones. It doesn't matter. But now this will give me an equation with 1 variable because now the b's will eliminate, right? We got the 3b's, and it was showing plus, but 3b, negative 3b's plus 3b's zeroes out or eliminates itself. So 12 plus 24, that'd be 36 equals 3a's plus 15a's is 18a's. Holy smokes, I wish someone had told me earlier, but the answer here is a is 2. So I'm going to divide both sides by 2. A, as it turns out, is 2. At least if we've done all the stuff correctly to this point. If I've made a mistake, this 2 could be off. It could be off, right? But hopefully we've done this correctly. Now A is 2, and we have so many equations to work with. We have 1, 2, 3, 4, 5 equations that we can work with to solve for either B or C. I know from these 2 equations that it's going to be easier to solve for B because now I have an A value to plug in. And it doesn't matter which one that I choose. I choose the one on the left because it has smaller values. So I'm going to take that 12. equals 3a minus 3b, but now we're pretty sure that the a value is 2. So I go in here, I say a, I'm going to replace that with 2, the 2 that we found already. And so I just need to solve this equation for b. So 3 times 2 there is 6, so 12 equals 6 minus 3b. And then I'd use some principles of equality to solve, so minus 6 from both sides. So I get 6 equals, this being negative 3b. Sorry, that's kind of small. But now I can divide both sides by the coefficient of negative 3, and b equals negative 2. Okay, so we got 2 and negative 2. All we need now is c. By the way, if this is correct, you can replace the a there with negative 2. And if you do, you should get a b value that is also, I said, replace a with 2. b would be negative 2. Do some analysis here. Make things easy for you, but you don't have to because the calculator really is going to do a lot of the work. We need to now solve for c. We have this system of equations that from the beginning. Neither of these two equations are going to help you solve for c. They help to solve for b, they help us to solve for a, but they don't have a c in there to solve. So you got to go back to the original system and use one of these to solve. I am going to choose the middle one because I don't see any coefficients for a or b, so I don't have to multiply it by anything. That's going to make that very pretty. So let's take a look. Okay, so I've got, 5.
Please, Jorge, that's not how.
5 equals, the a value that it gave us was 2. Now, I don't need that coefficient either. The b value that we found was negative 2, so that'd be minus 2. And then this would be plus c. Well, as it turns out, when you, let me see when I'm going to do this in green. When you combine those 2 minus 2 right there, it just really zeroes out. And you're left with, well, c equals 5. Now, if, let's say that you didn't choose that equation. Let's say you chose this one right here. Then you would have had 4 times 2 minus 2 times negative 2 plus c. And then you would have solved this for c. You would have still gotten 5. Same with this one right here. So as it turns out, it looks like that we've solved this correctly. If you were to replace a, b, and c into all 3 of these, you'd get true statements all around. And then everyone would be very happy. But let's go back to the quadratic, okay, because it wanted the actual quadratic equation. So it's y equals a times x squared plus b times x plus c. And in fact, it won't even be plus right there. But the a value that we found down there at the bottom, a was 2, so I've got 2x squared. The b value down here is negative 2, so that'd be, I'm just going to show it as minus 2x. And then the c value that we found was positive 5. And that's the equation right there. That's the quadratic equation.